Normally I have one class of 20, 25, and I have enough for that. I don't have enough for two classes of 49 people. So
There's 49 people in here?
no, there's two classes. I have 28 in second period.
I was like, ain't no way. I'm
Thank you.
It's like, well, we got you one.
All right, so what is an empirical formula? An empirical formula is the simplest formula. Now, in terms of math class, the simplest formula has the lowest or reduced subscripts. Okay? An empirical formula is referred to oftentimes as the simplest formula, or you can think of it as having the lowest or the reduced subscripts. So, if you have an answer such as what you had on the test, which would have been S206, you know that we would change S206 and reduce it into what? SO3. Because the 2 and the 6 can be reduced by 2. Correct. Now, this is the empirical formula. This, we're going to learn in a little while, is called the molecular formula. Now, we're going to learn how to calculate both of these today. Instead of crisscrossing with oxidation numbers the way we have the last week, we're going to learn how to find these mathematically today. Okay? So tomorrow on the lab, you're going to calculate them mathematically, and then you're going to write their names. Now, given some of us struggle with the struggle with the old system, what's the safest way to name them tomorrow? With a stock system. Now, I'm going to give you all a tip. What is the greatest Roman number you will have in the stock system?
7, 8.
Very good. What was that, Michaela?
7.
7. So tomorrow on the lab, if you're trying to write in the stock system, because the old system sometimes gets a little quirky, sometimes you have to name it in empirical, sometimes you have to name it with molecular, and you guys will come up to me and go, Miss Wall, do I name this with empirical or molecular? And I'm going to go, you can always use what system?
Stop.
And what's the greatest exponent you will ever have in terms of the Roman number? 7. Okay? So if you're looking at empirical and molecular and you're like, which one do I use? Think to yourself, my greatest oxidation number can only be a what? 7. So if I don't know if I should use the empirical or the molecular formula, I can't have anything greater than 7. So if I can't have anything greater than 7, I should narrow my choices. All right? Now, what if you have a formula like this? You have Na2SO4. Can I reduce it?
Yes.
To what? Why can't I, Precious? Precious over there going, no, I can't.
Oh.
Why can't I, Precious? You not feel good today? Just tired. Okay, why can't I reduce it? Not the reason. You are right that it cannot be reduced, though. I just need a different reason. Nope, not because it's a compound. Yep, Precious is right. It can't be reduced, but I need a different reason. Look at your subscripts.
Because that one goes on that one? Like, I don't know how to.
I'm not sure what that one and that one is. I need you to be more specific.
The 4 goes on SO4, but the 2 came from.
Don't worry about it that way. Treat each element separately. What if I tell you that? To treat each element separately. What? S has 1. Okay? If you look at the subscripts, S has a 1. can all the subscripts be reduced? No. Okay? 2, 1, and 4 cannot all be reduced. And because of that, this is already in lowest terms. So, this one is both the empirical and the molecular formula. And you will find that that one's ionic because it has a metal, right? Most ionic compounds are going to be both the empirical and the molecular formula. Okay? It will be both. Okay? If you say so. All I can say is bring a coat. When the heat comes on, we don't keep the heat on very high over here because Miss Rector's crowd has to do a lot of dancing. So we don't keep it very warm over here, okay? So in the winter, wear a coat. Wear a sweatshirt or a hoodie.
Well, I mean, that makes sense because it's cold outside and it's now it's like
Okay.
hot outside.
Right, it's supposed to be 94 and I'm under
Freezing in here.
Right.
You defrost if you go outside. Freeze back.
I swear, that's
There you go.
defrost.
That's a fabulous idea.
Literally.
Just defrost when you go outside. I'm not cold.
How?
I have all this insulation, people. I'm like a big old polar bear. Okay?
In here, it's not bad. It feels good.
Now,
Alright, this is everyone finna be.
so we're going to talk about the steps to find empirical formula. Now, the first step is sort of optional because it depends on how the problem is given to us. Some of the problems will be given to us in percents, and we will have to change it to grams. Some of the steps will already be in grams, and we will be able to skip step 1. So it depends on how the information is given to us. Now, we're going to do 3 different problems just so you can see 3 different styles. I do recommend you write all 3 down so that you understand how I can vary them on the quizzes and the tests. Now, we're going to change percent to grams. Number 2, we're going to change grams to moles. Remember, all chemistry calculations have to be done in what unit? Moles, which is why we've been learning to change to moles. We don't change and convert anything in grams. Every calculation from now to December will be done in moles. Number 3 looks really weird and sounds really weird, but you guys actually do this all the time in math class. So, you're going to take the smallest number of moles and divide it by itself. And then all other numbers of moles by the smallest number. So it's sort of like if you divide the left side of the reaction by 5, what do you have to do to the right side? Divide it by 5. It's the same concept, except that we have numbers of moles. So if you divide one number of moles by 5, you have to divide all the numbers of moles by 5. All right, and so the last step is just to write the formula. So we won't have to worry about any significant digits here because you're not going to wind up with a number. You're actually going to wind up with a chemical formula. Instead of crisscrossing the oxidation numbers, you will have come up with a formula by doing it mathematically. Now, tomorrow with the lab, you get a partner. you do not get notes. Okay, so you have to be able to do this without your notes tomorrow. Okay, you will have homework to practice it tonight. And you get a partner. You do not get notes. So if you don't practice tonight and your partner doesn't practice tonight, odds are good you're going to struggle. Your partner what?
My lab partner is usually Franco.
Oh, you're going to need somebody else.
I don't work tonight, so.
All right, so here's a typical sample problem. That's good. Elena's got time to practice tonight. She doesn't work tonight. Serenity's singing, thank God.
I'm quitting this one.
You're quitting?
Yes.
Okay. I'm going to put these up. All right, write it down. Come on, check out. Why are you sitting there? Write it down.
Anybody have any ibuprofen or anything?
I have one Advil.
I have Tylenol. That would put me to sleep. Won't it? No.
I was telling them, maybe Benadryl.
I just think. Oh,
Hey,
can you give me two?
You didn't have to bring up the whole big bottle.
My head is terrible.
He do. Because that is a big ridiculous bottle.
Here's for my 2 tickets.
Oh, I thought you were saying for.
What
No.
did you say?
Really?
The Pops concert next Tuesday.
It's $5 a ticket for 10.
I don't know. Who's nice?
Is he really good?
We still have people in ISS closed. Travesty.
Right, they said that we were right.
No.
I thought we were sending home.
Right, so what did they say to y'all?
They're
Don't
suspending people now if you don't have the right clothes.
They're usually repeat offenders. They're not usually.
Oh, I was gonna say, really?
Yeah, the people who are here.
For that meeting?
Cautious got suspended for 2 days.
Who did?
2 days, cautious.
I would imagine it's a repeat offense. There's somebody I know who got suspended. It was a repeat offense.
Miss Harvey said she was gonna suspend me. I don't even be wearing nothing crazy.
That's crazy.
I'm not caught.
Right, but then they yell at us for like coming to school. Okay.
Or being
They don't give us
tardy,
a place
but
to-
you have to.
All right, we got it written?
Let's not do that.
All right.
Because I'm gonna keep going.
Is it written?
Yeah.
I can go back and mark my target people in a second. All right, so when you look at this, we need to change percents to grams. What are we going to do?
Convert percent to grams.
I know that. I just said how.
Oh.
Listen to the question.
My head hurts. I can't think.
Do what? No, easier than that.
Am I?
Easier than that. What'd you say, Zara? Exactly. Okay? If we. Oh, that's what you said?
I get freaking shamed. That's not what I said.
I am so sorry, Allie. I apologize. That was exactly right. Your brain is working better than I thought it was, even with all that pain. Maybe you should come every day with a headache.
Hey. So they both answered the same thing. It still wasn't an answer.
It's correct. I thought I said, how do you change percent grams?
She just said convert percent to grams. Yeah, so we're both. Yeah.
Yeah, but I thought she said just change the percent to the grams by erasing it, which is what I want y'all to do. Okay? So if you add up all the percents, okay? If you add up all the percents, what do you get? A big number? What'd you say, Trevor? 100.
How do you know?
Oh
my God. I'm so sorry.
Okay, what do we do with percent composition Tuesday? When we added up all the percents, what would we have gotten?
Molar math. 100.
What would we have gotten when we added up all our percents?
There's a mosquito.
100%, right? Okay, use your calculator and check and see if that's 100%.
Okay.
Since clearly we have some doubters in the room.
Okay, well,
It's 100 point what? 100.02. Because remember what I told you. Am I going to make you chase down 0.1 or 0.0 something?
Why does it say error? Oh, no. I'm gonna take that.
I feel like I've been dropped back and forth, period. All right, so if you add up all the percents, you get 100%, okay? When you have a percent composition and you break it apart and you find the percent of each element in a compound, they have to add up to 100%. So if we assume that that's 100%, we can have a 100-gram compound, okay? So we're just going to take off the percent and we're going to write, instead of percent, grams. That's how we're going to change percent to grams. We're going to assume 100% becomes 100 grams. Is everybody with me on that? That's basically what I wanted you to tell me. To take the percent off and just write grams. You don't have to put it in a chart. You don't have to divide by 100 to make percent grams. You don't have to do anything mathematically complicated. You just erase percent and write G. Okay? Everybody with me on that? Now, step 2, everybody knows how to do. Everybody, even if you were struggling on the test, can change grams to moles. All right? So, draw your charts. What goes on the bottom for each one? All right? So, what has to go on the bottom line of the chart? Grams. What has to go on the top? Moles. Now, the nice part of these charts is we only have elements, so are we having to add up any compounds? No. Now, you do have to keep track of what the numbers go with, though. So, the 32.38 was grams of Na. The 22.65 was sulfur. And the 44.99 was grams of oxygen. So, you're going to look up the masses that go with those three. Now, does it matter if we use whole numbers or decimal place numbers?
No.
It does not. You can choose. All right. Most of you probably will use the 22.99 and the 32 point, I think it's 09, 07, and then 16. But if you want to round to whole numbers, it makes absolutely no difference. Now, I do recommend when you divide to take it out several decimal places because I have a couple of problems. If you round too much, it will give you funny answers when you get your whole numbers. So see how I took it out 3 places when I got my moles? I do recommend you do that. Nope, because you're not getting a numerical answer. We got our moles. Now, step 3 says divide by the smallest number. So what is the smallest number? Okay. So in math class, if you divide by the smallest number on this side, you have to do what to the other side?
Divided by the same thing.
So the other 2 numbers of moles have to be divided by the smallest number also. So we're going to divide here by the smallest number and here by the smallest number. Now, they might not be exact, but if they come out at 0.00 something or 0.999 something, it's the whole number. Okay? So I got 1.993. What is 1.993?
2.
That's 2. Okay? .98 is
4.
Now, what if I got 3.7? Would 3.7 be okay?
Yes.
No, that'd be an error. It should be really, really close to the whole number. Okay? If you get like 3.7 or 3.8, you probably have a math error. okay, they're going to come really, really close to that whole number. 3.99, 3.98,
So it's
3.00 something.
10, like,
Yeah, you could get something with 10.
no, like
Like 3.10.
10 away from like 90.
Maybe. I'd probably check my math. I'd probably double check. Okay, it should be really close.
Okay.
All right, so now we're ready to write our answer. Write the formula. So this 2 goes with Na. So Na has a subscript of 2. Okay? So the 1 goes with S. So S has a 1, and I'm just emphasizing. You don't have to write the 1.
Whoa, wait.
And the 4 goes with the oxygen. So O has a 4. And that is your answer. No, I just said you didn't. I was just emphasizing.
Where? Do you have a hand sanitizer?
It was over there beside Precious unless somebody moved it.
Dang. That's a beast.
What?
You okay over there today?
Me?
Yeah.
No.
Okay.
Like,
Did you get hit in the head with a volleyball yesterday or something?
What?
Did you get hit in the head with a volleyball yesterday or
No,
something?
I left early because I had a dentist appointment, but lately, like, I've been so, like, I'm ditzy, like, naturally, but, like, I've been so bad, like, I don't know what happened. It's kind of scary.
Okay. Now, here's one that has a twist in it. It's the same type of problem, but there's a mathematical twist. Okay? So write that down while I fix my absent people here.
Right, he better try again next semester.
Right.
He keeps texting me to remind, telling me what's going on with his doctor's appointments.
Okay, but is he on the
Is that
website
cool?
looking at the?
He says he is. He says he's keeping caught up.
I don't believe it.
We'll see what he comes back.
Okay, got one
supposed to be here.
question.
Right, why did he say he was in the lookout?
0.70624.
Right.
So what now?
We're getting 0.702.
Because it's the smallest. When you look at the 3 numbers of moles, the 1.4,
Nobody knows.
you're picking the smallest one to do it.
Oh, okay.
Okay?
They probably just left after they got them.
Yeah, perhaps concealed.
I forgot.
Oh.
Did you say solve this or just write it?
I said just write it. There's a mathematical twist that we need to talk about.
Twist?
Yep.
Oh, we just.
I know we started it.
That's it. And then 5 minutes later, it wasn't it. Like,
Oh, yeah, I missed one. Always be dropping that thing on the board. That's it, that's it. All right,
5 minutes
now.
later, okay, now multiply this, divide this, now add this. Okay, that's it. The next day is a whole different day. Right.
No, when I saw that A in -1, I was like.
All right. So when you look at this, we're starting it the same way. So what do?
G.
What do we do?
Add the distance to G.
All right. Put the G on. Okay, I get what you're saying. I was like, G, but I get it. All right. So that's K. And then 35.41 G of chromium. And then 38.03 G of oxygen. All right. So they all have G's now. What do I do next?
Look for the atomic mass.
Okay. Because we're changing them to what?
Moles.
Okay. So what goes on the bottom?
Gram.
Okay, so grams on the bottom. And what goes on top?
Moles. Whoa.
All right, so potassium is 39.1, chromium is 51.9, oxygen is 16.
I like how this oxygen in every like the fixing because now all I know is oxygen is 60.
that an 8?
Yeah. Just an ugly one. I like the way y'all agree. I'll be shaming my numbers over there now. All right, so, Xavier, what are we gonna do with those numbers once we have them?
Find the smallest one divided by
Okay, so which one's the smallest?
0.679.
Everybody agree with Xavier that 0.679 is the smallest?
Yes.
Okay, so I want all of you to divide by the smallest and see what numbers you get, because this is where the trick comes in, where the twist is in the question. Cause.
Oh. No, I did it right.
Wait,
You said it was supposed to be close.
to the whole number, but it's looking really small. Wait, neither of them.
Right, that's all why.
I told you there was a twist in this one. You gotta have some challenge in the problem.
Okay, but how are we gonna know if it's a twist or we did it wrong?
That's what we're getting ready to talk about.
Okay.
Alright, so if we calculate it. So when you see 3.49, or some of you might have gotten 3.5. Okay? What is 3.5? First of all, 3.49 is essentially 3.5. Up there for a moment. All right, 3.5. Now, Michaela said it's 3.5 or 3.5. How do you get rid of a half in math class? Because if we wrote the formula the way you've got it, you have K with a 1, CR with a 1, and O with a 3.5. Because the problem is, can you round 3.5 up to 4?
Yes. It's 5 and above, so I'll do it.
No. Can you round it down to 3? No. So what are we going to do with that 0.5? Think math class. How do you get rid of a half in math class?
Multiply by the reciprocal.
That was a fabulous answer. You need to come to the headache more often. They're firing on all cylinders over there today. So, how do you multiply by the reciprocal? What's the reciprocal of a half?
2/1.
Okay, so we're going to multiply by 2. So, when you get,
Wow. Flip it.
Okay. this is a half. So you are going to multiply by 2. Now, because you're in a first year class, you will either get a straight up whole number or you will get a half. Now, if you were an AP, you could get a fourth, you could get a third, you could get a half, you could get a whole number. But what did I just tell you? You would only see in a first year chemistry class.
A whole or half?
A whole or a half. So if you don't get a 0.5 or a whole number, so if you get any 0.7s, 0.3s, 0.2s, what do you know happened? You got some kind of messed up math, because you're either going to get 0.5 or you're going to get a whole number like we got there. So when you multiply by 2, you get K2, CR2, O7. And that's your answer.
Wait, what about the one?
What? Hot?
We stayed at the auditorium as long as we could.
Oh, I gave Xavier.
No air in the auditorium.
Uh-uh.
Yeah, go ahead and be happy about that.
It took Xavier. Well, how long have y'all been selling tickets?
You know why? Because they're getting a remind every period today to ask.
Okay. I was like, it took y'all long enough. I've been waiting. I refused to ask y'all to sell me a
That's
ticket.
right. That's right.
Refused.
I do have change.
So what about the one?
Where do you get
The for the CR, the chromium?
Yeah. What about?
Oh, you said most of that too. For that.
Yeah, you gotta do it all of it. Remember, it's just like in math class. You can't just do it to 3.5. You gotta do it to all of it. right? Does that make sense?
Yeah.
All right. Last empirical formula one, and then we're going to switch. All right.
Switch.
Yep. I'm going to write it down, and I'm going to get you started. Then I'm going to let you finish. And then we're going to switch to molecular.
Notes are so long.
It's only a word problem.
Am I supposed to be writing this down? These problems?
Yes, James.
Oh my god! I just write the work.
Yes, dear.
It's fine. I understand what I need.
It's almost 9:30. You can't read that clock either?
I didn't even see it.
Right.
I can read. I can.
You can read the time?
Yeah.
Okay. Well, I told somebody in fourth period the other day it was 2:45. And they said, what does that mean?
No, I'm not giving it.
You know what 2:43 means? Okay. They were like, does that mean like 275?
Look, y'all see it.
No, seriously, that's what I
275. 275.
That's how it
Yes, it means 15 too. Thank you.
15.
15.
Means 15 minutes to the hour when you say quarter to
That should
three.
be 25 minutes to the hour then.
No!
A quarter is 25.
This is the same conversation I had third or fourth period. Quarter to three does not mean 25 minutes to the hour because it means it's a quarter like 25 cents. A quarter has to do with dividing up the clock into quarters or
How would it be
halves.
20?
No! I'm not teaching time.
15.
Write the problem down.
Okay.
I'm done with the time.
Honestly, they are my fault. This is just
I just told him it was 2:47 and called it a day.
Yeah, see, I could probably understand.
I told them it was 2:47. They were
You
okay.
can understand that.
240.
Huh?
You know, 2 minutes. You said it was a quarter to 2.
Yeah, I gave up after 2 minutes. I just said it was 2:47 and moved on.
Was it 247?
It was 2:45 when we started.
Yeah.
At 2:47, I told him it was 2:47.
Y'all was talking for 2 minutes about it.
No, I tried teaching it for 2 minutes. I gave up.
Honestly,
People told me it was 2.75. Then they said it was 25
And my
cents.
pet peeve is when I ask for the time and they round it or something. I want to know
Right.
the exact minute.
oh my god. It would be
Don't
like.
round it.
Yeah, like it'll be like.
7:42.
Alright.
Oh, it's 7:50.
So when you look at this question, what's different about this one and the other ones we've done? Do what? They're already in grams, so we're not going to have to change anything. What else is different?
Empirical. No. Sorry, I didn't write this.
You only have 2 elements.
It's compound.
It's what?
It's compound.
It's a compound. So one of the masses is a what? It's a combined mass. It's not separated. See how it says 10.5 grams of the compound? It's combined. It's not an individual element's mass. You have to get the individual element's mass. This is the grams of what? Oxygen. So you know oxygen, but we don't know phosphorus. Phosphorus is B, but we don't know what it is. So how are we going to get
Subtract. I mean, that's what I meant.
it? I knew you meant subtract.
Thank you.
Okay? So we're going to take the 10.150 grams, which is phosphorus and oxygen together, and we're going to take the 5.717, which is just the grams of O, and we're going to subtract them to get the grams of P. P as in phosphorus. No, just phosphorus. So 10.150, subtract 5.717, and we get 4.433.
What?
So you're going to use your grams of phosphorus and your grams of oxygen to find the empirical formula. So find that for me. We've done 2 together. So you take those 2 numbers and find me the empirical formula. And then we're going to find the molecular formula next.
Ew. Disgusting. Oh, man.
I'll see that. Wait, 30.97? Why?
All right, how are we coming? Got an answer for me?
Yes.
Yes? All right, so when we took 4.433 grams, changed it to moles, we had what, 31? I'm just going to use whole numbers. 5.717, 16, 1 mole. Okay, well, give me your number of moles here.
What?
Give me your number of moles for phosphorus.
25.
Okay, the moles. When you divided 4 by 31, what number of moles did you get?
0.1431.
Yeah, that's what I'm at.
All right. Janiyah, tell me the number of moles you got for oxygen.
0.3573.
Okay, that's what I needed. All right. Did we get something to look like that?
Yes.
Okay. Yes? No? Any of those numbers look familiar?
No.
All right. Where are you lost, Elena? You did not punch in the calculator if you got that. Okay. 2.5. All right. So when you write the formula, you have P1, O 2.5, put a 2 there, P2, O 5. Everybody good?
205. Oh, yeah, I don't know why. Yeah, that's what I got.
Okay. Let's talk molecular formulas.
Wait.
What?
Okay.
All right. So a molecular formula.
It's fine.
Yeah, this is new.
Like a new set of products.
Well, it goes with empirical. All right. It shows the actual number of atoms. Now, we've actually already done this. We did it with the empirical formula, so we'll just review for a second. Okay? The thing that makes it different is it may or may not be able to be reduced. Okay? So, if you have C2O4, C2O4 can be reduced into what?
CO2.
Okay. So, this is molecular. This is empirical. But, if you have something like, let's just say we have CaCl2, can it be reduced?
No.
Mm-mm. That's both molecular and empirical. Okay? It's both the molecular and the empirical. Because it can't be reduced. It's already in lowest terms. It's got a 1 and a 2 already. Okay? So C2O4 can be reduced. So, excuse me, it's molecular. But CO2 is empirical because it is in lowest terms. But CaCl2, we can't reduce. It's already in lowest terms. So it's both. Does that make sense to everybody? Yes?
Yes.
Okay. So now we're going to calculate a molecular formula. Now, we need two things. Number one, we have to have a molar, or I'll put in parentheses, a formula mass. Because remember, this has multiple names. We can call it formula mass, we can call it molecular mass, we can call it molar mass, we can call it anything, but you got to have a mass. And number two, you got to have the empirical formula. Now, the first problem we're going to do, I'm going to give you the empirical formula. Tomorrow on the lab, I'm not giving you the empirical formula. You have to do what we just spent the first part of class learning. You have to find the empirical formula first, then you're going to do this part. Okay? Does that make sense? Yes or no?
Yeah.
Okay. So, you're going to take the given mass, which is the molar mass. You're going to divide it by the mass. You add up, which is the empirical formula mass. And when you divide, you're going to get a whole number. Like 1, 2, 3, 4, 5. Okay? You're going to take the mass they give you, which is that molar mass. You're going to divide it by the mass you add up, which is the empirical formula's mass. Okay? That's just like adding up molar mass. You already know how to do this. Almost nobody got it wrong on the test. Now, when you divide, you're going to get a, even you, Xavier, you got it right. All right? You're going to get a whole number. Now, you're going to take this whole number and you're going to multiply it through the empirical formula. And when you do that, you're going to get the molecular formula. Okay? You're going to multiply the empirical formula by that whole number, and you're going to get the molecular formula. Now, it looks really complicated. It is not complicated. It's a whole lot less work than the empirical formula. All right, are we there? Yes, no? All right, so write that down, and we'll do it. Now, I don't think we're going to have time to work a combination problem. Do you want me to post last year's video and tell you where the section of the video is where there's a combo problem from last semester?
Yeah.
Okay, I'll do it. I'll do it during the third period. And I'll tell you what minute to go to so you can fast forward all the way to the
Go
end
to
of
your
that.
page and go to home or homework.
Yeah.
It'll be on there.
Yeah. Yeah, because it'll just combine empirical and molecular together in one problem. He's got it. Two.
You bring me.
I don't know yet.
You bring somebody.
I'll bring somebody. The only one I know it won't be is Larry, or I mean Shelby, because she's a dance till 10:15.
10:15 at night?
Well, it gets done at 9:45. They just got a half-hour ride home.
Oh my gosh.
I know.
Okay.
Hey,
Xavier's the quietest one of the bunch.
you think this is a loud group? You need to go back
Just
fourth
kidding.
period.
Oh, yeah, y'all fourth period. I don't know how you
Yeah,
have on
Video.
Oh, you got it.
Yeah,
No. I know.
I'm as ridiculous as always.
All right. So what's the mass that's given to us? The mass is given. I got it. So it goes on top. Okay. So that's on top, right? Divided by. Okay. So the mass is given. Divided by what you add up. All right. What's the only thing left for you to add up? What's it say? Mass you add up.
Empirical formula.
Okay. So what's your empirical formula?
P2O5.
How do you add up the P2O5?
Well, we just did.
How do you add up P2O5?
Oh, that's a lot.
That's a lot.
Yeah, it's a couple few steps.
Right, and I was, is it expected?
How's a couple few steps you weren't expecting? How many P's you got?
2,
How many O's you got?
5.
Okay. We're even going to use whole numbers for Janiyah over there because it's too many steps. Okay. So 31 and 16. So it's a little easier on Ms. Wall's math. So 2 times 31 is 62. All right.
31 and 16, the atomic mass.
Yeah. I got it off the periodic table. These are your masses off the periodic table.
That's what I was doing wrong.
What were you using?
I was using the numbers at the top.
That's the atomic number. You got to use the atomic mass. We're not using the atomic numbers for anything.
So that's.
Not right now. We will in a week or a couple weeks, but not right now. So that'll be what? 64 plus 16, 80. That'll be 80. That'll be 142. Okay.
So is that what I put on the?
All right. So this is going to go where?
On the
The
bottom.
mass you add up goes on the bottom. Oops, too far. So 142. Now, when we divide, we have to get what kind of number?
Oh, number. I got 2.
I got 2.
Okay, I didn't turn my calculator on and I punched it all in, so I'm going with Janice. I got 2.
Yeah, 2.
Okay, now, that means what this tells you is the formula was reduced by 2.
Oh.
That's what that 2 means. If you got a 1, it would mean the formula was reduced by 1, which means it wasn't really reduced. Okay? If you get a 6, the formula was reduced by a 6.
I got
Now.
1.99.
1.99 means it's a 2. Okay? 1.99 equals 2. Now, if you got 1.6 or 1.7, that would tell you have a math error.
So,
Okay? So you're taking the whole number of 2, and you're doing what?
multiplying it by the empirical formula.
So the empirical formula is P2O5. So what are we going to get?
Oh. P4O.
P4O10. So this is our molecular formula. Now, I'm going to caution you here, and people are going to laugh at me.
Wait a minute.
What's wrong?
Oh, I was thinking about the other thing we did.
Okay.
I thought the half thing.
Okay. There will not be a half thing here.
Just make sure I'm calculating this right. So once you get that 2, you just multiply that by.
Multiply it through the empirical formula, yes.
So
Now,
you get-
when you get to this step, and you get this answer, every year, every lab, every quiz, I have people who look at that answer and then slash it out and write P2O5 right here. Now, the point of the question is to figure out what it was before you reduced it.
Oh.
So if you reduce the answer, you go back to what was in the question. Don't reduce here because you're trying to figure out what it was before it was reduced. But every year I have people who scratch out their work at the end and reduce, okay? Don't do that, all right? That's not the point of this question. All right, one last one. You don't even have to write it. Just try to solve it, okay? Just to practice yourself.
Did you say one last?
You don't have to write it. Just solve it.
What's the way
I got 5 minutes.
I got 0.
The simplest.
Yeah, I know, it's a typo. One of these days I'll remember to take that I out of there.
I'm good.
Spelling was never my strong suit in school.
I was gonna say, what they didn't give us the letters, but I see it.
CH.
So is it?
The empirical formula is CH.
Okay.
I don't know why I think it's it.
So the number that
I
you
did not feel like reading that periodic table.
tell me I gotta walk up there.
Can I use whole numbers or you can not like?
No, you can use all numbers.
Okay.
And I'll tell you which ones we're going to do on this.
Oh.
To practice tonight, and I will post
Oh, you keep going from
the one where the combo one is because it's on the homework third period.
Is it just me or is ours just me?
Oh wait. Thank you.
Welcome.
I think
So what now?
I think it's gonna be a no.
It's C and H, so carbon and hydrogen or something.
Yeah, that's what I just thought.
Did you get it?
No.
So,
I don't think I did it right. I got 6.008 when I divided.
Yeah, 6. 6.006.
Oh.
You sure did 6.
Okay.
Princess, on your way back to your desk, fix your shoes.
Okay.
I didn't walk around and check because y'all did so good about putting your straps behind your feet, but fix your shoes. Did y'all get that far?
Yes, that's where I am.
Okay. You take the mass that's given, which is 78. You divide by what you add up, which is 13. So 78 divided by 13 is 6. 6 times CH is C6, H6.
That looks so wrong. Like, I really
All right, it's actually the formula for benzene. Now, on the front side, the one that says empirical formulas. That's because Elena still has 3 of them on her desk.
Oh.
All right, we're going to do number 1, 3, and 5 on the front. 1, 3, and 5. And on the back, we're going to do 1, 3, and 5.
Wait, which one's the front and back?
I was reading the questions when I said them. Sorry, I was reading the questions. Okay, so 1, 3, and 5 on both. Sorry, I was reading the questions.
Take my calculator, please.
And I will post the video of the combined problems so you can see 3 and 5 on the back.
They have two. I have two.